Hey everybody, Dr. A here, and in this video we are going to be exploring an example where we are going to be doing some dead load and live load calculations. So let's take a look at the given information. So we are told that a 25 foot by 30 foot by 6 inch, and you can assume that's the thickness, reinforced stone concrete garage slab will be supporting passenger vehicles. So this is maybe a slab of a garage for a house. And then we're being asked to compute the minimum design dead load due to self-weight and live load in kips, okay? So let's go ahead and write solution, and you want to write all of this down, and it may be a good idea to draw a figure. So remember, if you're ever given a problem and you're not quite sure what, how to visualize it, because maybe a figure is not given to you, then it's okay to draw one out. So let's go ahead and sketch out what we think this concrete slab may look like. So in 3D, I'm going to sketch something like this. I'm going to put a thickness here. And so we'll have this slab that has this general sketch that looks like this. And of course, one of the dimensions of this slab will be our 30-foot long dimension. The other dimension will be the 25-foot long dimension. Then, of course, the thickness of the slab, that's our 6 inches or half a foot dimension, okay? So let's go ahead and use ASCE 7 to help us, all right? We're going to just refer to ASCE 716. There are some other good sources out there you could use, like IBC, International Building Code, as well, but we're going to just go ahead and use ASCE 716 here, okay? So let's look at the dead load first, okay? So the dead load is going to be due to the self-weight, okay? How much the slab weighs itself. And so from ASCE 716, table C 3.1-2, we can get the unit weight of concrete is 150 pounds per cubic foot, or we can write that as PCF, okay? And so to get the total dead load in terms of kips, what we can do is we can say W dead equals the unit weight of concrete times the volume of the slab, okay? V sub S is going to be volume of the slab. Now, how do I know that? How do I know that weight is unit weight times volume? Well, you can look at it from the units perspective. If the unit weight of concrete is pounds per cubic foot, and then you take that value that has units of pounds per cubic foot and multiply it by a volume, which has units of cubic feet, that'll give us a total weight, okay? So what we can do is we can say this is 150 pounds per cubic foot. We can multiply that by 30 feet times 25 feet times half a foot. That half a foot, of course, is our 6 inches. And so the dead load is 150 times 30 times 25 times 0.5. And so that will give us 56,250 pounds, or of course that would be 56.25 kips. Now, another way you can think about this, if you would rather visualize it a different way, is you can resketch, this slab. I'm just going to basically redraw my figure again. Of course, my drawing looks a little worse right now. That's okay. Hopefully you see what I'm trying to sketch. And I can think of it as its self-weight is a distributed load, okay? So we can think of this as a self-weight as a surface load. And, of course, this is a surface load all the way across this slab. So all of this little purple grid I'm drawing here represents a load spread out over this area. And sometimes we would call, if you have a load spread out over an area, maybe you call that Q, and Q would be equal to a unit weight times the thickness, So you could say Q is equal to 150 times 0.5, which is 75 PSF, okay? And then you can say W dead equals Q times area. And if you said W dead is Q times area, then 75 PSF times 30 feet times 25 feet. And of course, you get the same thing. You would end up with W dead equals 56.25 kips. So a couple different ways of thinking about this. Think of it as dead load weight is unit weight times volume, or you can think of it in smaller components as a surface load in PSF is the unit weight times the thickness of the slab. Then the dead load is that number, which I called Q, times the area of the slab. But obviously, you should be able to see this algebraically, that this comes out to be the exact same as thinking about it as in terms of unit weight times volume. Okay, so just two ways of thinking at it. But regardless, the dead load of the slab in terms of its self weight is 56.25 kips. Now let's look at the live load. Okay, live load. So live load, we're going to use ASCE 716 table 4.3-1, okay? Now in the left column where it says occupancy or use, there's pretty much right in the middle of that page, there's a section on garages, and it says passenger vehicles only, and it says our uniform unreduced live load is 40 PSF. We do have a passenger vehicle. And then the question is, can we reduce it? Well, look at the very next column, live load reduction permitted, and it says no here. So we would say the live load is not permitted to be reduced. Okay. Now, if you also notice where it says garages, it says in parentheses, see section 410. If you've got ASCE 716 with you, why don't you flip with me? You can flip to section 410, and it also has a subsection 4.10.1 on passenger vehicle garages, and it says, I'm going to read it quickly, floors in garages or portions of a building used for the storage of motor vehicles shall be designed for the uniformly distributed live loads of table 4.3.1, which we just looked at, or the following concentrated load. Number one, for garages restricted to passenger vehicles accommodating not more than 9 passengers, 3,000 pounds, acting on an area of 4.5 inches by 4.5 inches, and for mechanical parking structures without slab or deck, so on and so forth. So the thing is, notice the wording there. It says floors in garages or portions of a building for storage of motor vehicles shall be designed for the uniformly distributed live loads of the table or the following concentrated load. We are using the distributed load given in the table, okay? So I'm just going to refer this to you. I'm going to say see section 4.10.1 for further information. Okay, but that further information does tell us we just use the 40 PSF, and there's an or statement there. You could say it says use 40 PSF or another value that it describes in that paragraph, but we're going to use the 40 PSF. So we can't reduce it though. So this is what it is. This is the minimum design live load. We're not allowed to reduce it because table 4.3-1 says no, you can't reduce it. So finally, we can calculate a W live load as this 40 PSF times the surface area that is the garage slab, basically. So we'll say 40 PSF times 25 feet times 30 feet. And how do I know? How do I know it's this 40 PSF times this area? Well, again, look at your units. What is a PSF? That's a pound per square foot. And if you want a final value that is a force, you need to multiply this pound per square foot times an area to get your units behaving correctly. So 40 times 25 times 30, that gives me 30,000 pounds or 30 kips. So to summarize, our dead load, W dead, was 56.25 kips, and our W live would be 30 kips. And so a little commentary here, these are values to use to design the slab. So that's all why we're doing this. We're calculating these dead load and live loads such that we can then design the thing that is supporting this dead load and live load. In this case, it would be a concrete slab for a garage. Okay, so that's going to conclude this video. Thanks for watching.